Quadratic equations. This is Unit 5, Lesson 1. Try these problem number 1. So we're going to start by rewriting this equation, which is in standard form, and we're going to rewrite it in what is called vertex form. So we do need to show all the algebraic steps to do this. To receive credit, I'm going to add 3 to the opposite side. My next step will be whenever the value, the leading coefficient, is anything other than a positive 1, I need to factor it out. Now I need to figure out what is this special term. So we want to have this term so I'm able to factor this correctly. Now this term can be determined by taking the b value, dividing it by 2, and we were going to include the sign in front of that. Taking the b value, dividing it by 2, and then squaring it. So 2 divided by 2 is 1. It is a positive 1, and positive 1 squared is 1. But I didn't actually just add a value of 1 to the right-hand side because I need to keep the equation balanced. The right and the left-hand side need to remain balanced. I added actually a value of 4. So on the left-hand side, I also need to add 4. Now that I've determined this value, I could come off to the side and I could factor it like so. 1 times 1 is 1. Adds together to give you 2, and so 1 and 1, they multiply and they combine. So this would factor into x plus 1 and x plus 1, but there's a shortcut to all of this. The shortcut is when you have the exact same quantity twice, we can write it as x plus 1 squared. And even faster than that is not taking time to factor, is take this value, so you've divided it by 2, the b value divided by 2, take this value with the sign in front of it, so a plus and a 1, and this is exactly, so instead of taking time to do all of this work and get to this point, once I take b and divide it by 2, keeping the sign in parentheses, and squaring it, this is what's going to go into this place right here. Okay, now to write it back into vertex form, I move the 7 to the opposite side. And this represents factor form. So vertex form. If I went ahead to this original function and I graphed it on a graphing calculator, and then I graphed this, you'd see they're exactly the same function. Let me show you. This time you can see I've taken the function that I'm provided in standard form. I can graph it. We see what it is in blue. I come back and now I'm going to type in what I have. And this is a great way for you to check when you're done on your assessment, did you correctly rewrite it in vertex form. So I'm going to graph this, and the red should be directly on top of the blue. That's exactly what I have, so I feel confident in my answer. Okay, what are we going to do next? So after we do that, we're going to identify what the vertex is. So it lies to us on the inside. It tells us the truth on the outside. This is the vertex. The next thing we're going to do is we're going to identify the y-intercept. We can come back up to standard form. It's this number in back called a constant that has no x with it. And now we're going to algebraically determine the x. So how do we algebraically show how to achieve the x-intercepts? So to do this, we have a couple different ways. We can come back up here. This is in standard form, and I could use the quadratic formula. A lot of people prefer to use that to show all the work. An alternative is to take this, and notice that when we find the x-intercept, when we find the y-intercept, x is 0. Well, when we identify the x-intercepts, it's just opposite. Y is 0. So I'm going to go up to this equation, and I'm going to put a 0 in for y. Now, if you don't like the method that I'm using, remember, you can come back up here and use the quadratic formula. You'll achieve the same answer. So I'm going to solve now for x. Add 7, add 7. Okay, divide by 4. 7 over 4 equals x plus 1 quantity squared. This tells me I'm going to have 2 answers. So plus or minus the square root of 7 or the square root of 4. Now, the square root of 7 I can't break down, but I know the square root of 4 is 2. And now to isolate the x, I'm going to subtract 1 to the opposite side. So when the 1 moves over, it's negative. So negative 1 plus or minus the square root of 7 over 2. This answer is totally fine. You may have seen if you looked at what was provided to you that maybe they used the quadratic formula. It was just in a little bit different form. So I know that if I write 2 over 2, it's the same thing as 1. So if I change this to 2 over 2, that's the same thing as negative 1. And it may have been possible that on Mr. McFarland's answer key it looked like this. It's just in a different form. These are the exact same thing. Whether we write this as negative 1 plus or minus the square root of 7 over 2, or we write it in this form. Equivalent forms. And again, you could have found the x-intercepts by actually by actually using the quadratic formula. So let's go ahead and graph this. I'm going to find -1, -7. Believe that's right. Okay, that is right. So I have -1, -7. I'm going to find x-intercepts. Oh, these are not pretty x-intercepts. I'm going to find a y-intercept of 0, -3. And then one thing to consider with this, let me move this up to the side here. Okay, an alternative, by the way, to graphing this, because we do want to graph this, is in using algebra to do it, is to recognize that when I think of the parent function of y equals x squared, my input is 0, output is 1. I could have put 0 down here to make it even better. Input is -1, -1 squared is 1, -2 squared is 4, 1 squared is 1, 2 squared is 4. So we did this in the last unit. Now how can I take this and relate it to this problem? Well, notice that the number out front, whether it is in vertex form or it's in standard form, is a 4. So I'm going to multiply 4 by the y's. So this becomes a 16, a 4, a 0, a 4, and a 16. So here's my 0, 0. I'm going to go to the left one and up 4. Left one and up 4. Okay, and I'm going to go to the right one and up 4, so it should be right here, should actually be it. And then I'm going to go to the right 2 and up 16. So we know this is 7, I need 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I go left 2 and up 9 as well. All right, so we have this very skinny parabola. I need to see your work, and obviously I'll ensure that there's enough space in your test where you can show your work.